Hello guys, welcome to the second section of integration. In this section, we're gonna to discuss about trigonometry ratio use integration. At the first, when you have the cosine x, the derivative is minus sine x. Therefore, the integration of minus sine x is cosine x. But in the last, we have a minus. Therefore, integration of sine x is minus cosine x plus c. But another one, guys. In here, we have the sine. Integration of sine is cosine. Therefore, the integration of cosine x is exactly sine x plus c. What's your idea about the tangent? The derivative of tangent x is 1 plus tangent x power 2. Therefore, the integration of 1 plus tangent x dx is exactly the inverse of, tangent x, and therefore our total integration is tangent x plus c. But about the cotangent, the derivative of cotangent is 1 plus cotangent x power 2 with a minus. If I gonna to calculate these, at the first I put the minus in here and minus in the out, and they can cancel each other. Therefore, this value is exactly cotangent, but in the last we have the minus, add in here is minus cotangent x plus c. Therefore, this integration must plus cotangent x dx totally is minus cotangent x plus c, guys. That was so simple. Therefore, I prefer to follow a little with the higher speed, and after that stack in some tricky questions. In here, I just use the linearity of property in integration, and if you're gonna to calculate this one at the first you part to the third part, and you start to calculate step by step. In here, the integration of sine x dx is exactly minus cosine x, and the integration of cosine dx is exactly, sine x. Exactly, guys. We had a sine x, derivative is cosine x, but in integration, the procedure is inverse of that. Therefore, the integration of sine x is minus cosine x. But in the previous, when your function was cosine x, the derivative was minus sine x, but in here is totally inverse of this. Cosine x dx is sine x. Okay? Therefore, this part is minus cosine, this part is minus sine, and integration of 2 dx is 2x. So our total answer is minus 3 cosine x plus 2 sine x plus 2x plus c. Oh, a little strange. What's your idea about this, guys? At the first, I put the 1 for every statement, plus 1 dx plus integration cotangent 2x plus 1 dx minus 2. Do you agree with exactly plus 1 minus 2 and integration dx? What is that exactly? That is derivative of tangent. Therefore, this part integration is tangent x. And another one, if we put the minus in here and output, this part is cotangent, and in the minus in the last is minus cotangent x, and here is minus 2x plus c is our total integration. Guys, if you sometimes be misunderstood, pause and come back, because if I don't understand what's your level, if you are so basic, instead of of just watch for once, start to watch for several times, and it cause you can understand better. But in this journey, we start to calculate derivative from very beginning. In the previous session, if you are also have trouble with this issue, please at the first follow the section 1. Wow, it's so tricky question. What is the integration of this part? At the first, yes, you can know you must separate to sine 2x, sine 2x in the numerator. But from trigonometry formula, if you're not mastering trigonometry, I record the trigonometry notice in playlist. You can follow trigonometry playlist and you can see all of these things with detail. Therefore, sine 2x is exactly 2 sine times cosine. I put in here, and after that our calculation is 2 sine, and they can cancel each other, and answer is exactly 1 sine power 2x times cosine power 2x dx. How can I write this? Is sine power 2 plus cosine power 2. If I factorate this, our total answer is integration of this divided to this part is 1 plus cosine power 2x dx, and this part divided to this factor is 1 plus integration of 1 divided to sine power 2x dx. But 1 divided to cosine 2, we can use this formula, and in here this formula is integration of 1 plus tangent power 2 dx plus this part integration of 1 plus cotangent 2x dx, and this integration we calculate in the previous. In here exactly, of course, in here is cotangent and tangent, therefore is tangent x, but in here we need put minus, and minus in the outside is minus cotangent x plus c. Do you agree with me? Okay, started to calculate this part again for yourself. Guys, our question is a little tricky. I can use some simple question for you, and after that, yes, what is the integration of, for example, sine? You immediately say your answer. But in here, I just gonna to challenge you with some complex question. But the exponential function, in the derivative, if you have e power u, derivative is exactly u prime times e power u. Therefore, in integration, operator is inverse. If your function is integration of e power u dx, therefore answer is e power u, not times, but divided to u prime plus c in here. For example, if they give you e power 3x, they're gonna to calculate derivative, you say 3e power 3x. But if they give you e power 3x and you're gonna to calculate integration, is e power 3x divided to 3, not multiplied by 3, plus in the last by c. But in here, guys, e power 6x plus y is in here is a constant. But if you're gonna to calculate derivative of this part, is linear, and answer is 6. Therefore, divided to 6. But we go to the logarithm functions. In the previous, if I tell you, you consider that is your function. If you're gonna to calculate derivative, yes, is u prime. If you not master, you can follow our derivative playlist, and I explain in that place all these rules with all details. If your function is L and U, derivative is u prime divided to u. Therefore, if exactly give you this, u prime divided to u dx is exactly ln of u plus c, because they are inversible, and some things you take a derivative and after that you take an integration of from this derivative you came back your initial function. But in this question, integration of tangent dx, yes, at the first I split to ratio sine x divided to cosine x. And if you see exactly derivative of cosine minus and minus in the out, exactly is in the top. Therefore, our answer is ln cosine x plus c. But in the last we had a minus and I put in here. What about this cotangent x dx? If you're gonna to calculate this, at the first you open cotangent to cosine x divided to sine x. But this part derivative is exactly in here and you can use with u and u prime. Yes, and answer is ln sine x plus c. Thank you for watching this movie. Please subscribe our channel and follow our next video. Take care. Bye bye.